Hi, welcome back to the Unit 1.4b video. In this video, we're focusing on limiting reactant and theoretical yield. This is the second part, so make sure you watch part 1 before you watch this part. Okay, so chemistry and cooking analogy. We discussed in the first video that your balance equation is like your recipe, tells you the ratios of ingredients in food or reactants and products. The limiting reactant is the ingredient or reaction you run out of first, and theoretical yield is like the most amount of food you can make or most amount of product you can make. And in the last video, we talked about this grilled cheese analogy, which sort of helps us to ground ourselves, and that's sort of the thinking we do when we are tackling these types of problems. We also focus on the limiting reactant question, which ingredient will you run out of first? And we looked at two methods, method A and B, for how to determine the limiting reactant. What we're going to focus on now is the maximum amount of food you can make, which is our theoretical yield. And we, again, will look at method A and B. So let's start with method A. This is the method A for the limiting reactant, which was comparing two reactants or two ingredients and figuring out which one do you have, if you have more or less than you need. So, for example, for the 10 slices of bread, we could ask ourselves, how many slices of cheese do I need? According to our recipe, we would need 5 slices of cheese. So we determine, oh, I actually have 7, but I only need 5. Well, that tells you that cheese is in excess, which makes the other reactant, the bread, the limiting. For the case where we have, if we instead of looking at the bread, we will chose to look at cheese, we could say for 7 slices of cheese, how many slices of bread do I need? Again, we know from our recipe or balanced chemical equation here that we would need double the amount, so 14 slices of bread, and you only have 10, so that means that the bread was the limiting. Okay, for the theoretical yield part, we need to take the focus on the limiting reactant. So I have identified that bread is our limiting reactant, and that's all you need from method A, is to know the limiting reactant. Once you know what that is, you're going to use your limiting reactant to figure out how much food or product you can make. So for the 10 slices of bread, we can ask ourselves, how many sandwiches can I make with my limiting reactant, the 10 slices of bread? Okay, so for that, you know from the recipe that you could make 5 grilled cheese sandwiches. So this value, the 5 grilled cheese sandwiches, is the most amount of food you can make, so your theoretical yield. Let's try the same thing with a chemical reaction. So we want to know the theoretical yield if we combine 12 moles of N2 and 20 moles of H2. Now, using method A, back in the first half of this video, we found that H2 was the limiting reactant. So we're going to start with H2 now for the theoretical yield part. And we want to know for 20 moles of H2, how many moles of NH3, which is the product it can make. Okay, so once again, we're relying on dimensional analysis. We are starting with 20 moles of H2. I'm putting it over 1 just to make it into a fraction. And then I'm going to multiply this fraction by the conversion factor, which I get from the balanced chemical equation. So the values I'm focusing on are the 3 moles of H2 and the 2 moles of NH3. And the reason why I'm focusing on those is because I want to go from H2 to NH3. Question is, what goes in the bottom, 3 moles of H2 or 2 moles of NH3? Of course, it's the 3 moles of H2, and that's because in doing this problem, we want to cancel out H2 and solve for NH3. So once we do the math, we get 13.3 moles of NH3 can be made from the H2, and that is then my theoretical yield. So from my limiting reactant, from my 20 moles of H2, the most I can make is 13.3 moles of NH3. So to quickly recap, if you're using method A, you first determine your limiting reactant. Then you use your limiting reactant to find your theoretical yield. Okay, what about method B? Cool thing about method B, if you did method B for your limiting reactant, you already have your theoretical yield answer. So you can celebrate, you can party. All right. So what do I mean by that? Let's go back to the method B work that we looked at in video 1. We said in video 1 that when we're using method B, we're trying to figure out how much product or food we can make from each ingredient separately. And we have to do both of them so that we can then compare. So for the 10 slices of bread, we can make 5 sandwiches. For the 7 slices of cheese, we could make 7 sandwiches. And so we chose the one with the smallest amount of sandwiches or food we can make because we can't make more than we have, right? We're going to run out of the bread before we can make 2 additional sandwiches. So that tells us what our limiting reagent was. But this answer, the 5 sandwiches that we can make, that's actually our theoretical yield. So the theoretical yield here is 5 grilled cheese sandwiches. It's the same answer you got before with method A, except for if you did method B, when you're finding the limiting reactant, you already got the answer. So you can stop. Like, that's your theoretical yield. Okay, so let's look at the same thing for method B when, with the chemical equation. This was the work for the limiting reactant. And recall, we were trying to figure out for the 12 moles of N2, how many moles of NH3 can we make? And for the 20 moles of H2, how many moles of NH3 we can make? And we got our answers for in each case. And we said that, oh, well, H2 must be our limiting reactant because it produces the smallest amount of NH3. Once again, that smallest amount of NH3 is your theoretical yield. So that's your answer. So you can actually stop. If you do method B, you get the limiting reactant and theoretical yield at the same time. Okay, so let's just quickly recap what we've covered in this video. We're using the food analogy to sort of understand limiting reactant theoretical yield. Remember, the balance equation is your recipe, not how much you have or need. Your reagents are your ingredients, and the product is your food. For method A, we looked at 2 methods here, method A and B. For method A, it compares the 2 reagents. So you figured out, well, how many moles of N2 do I need to react with 20 moles of H2, for example? Whatever, if you determine that you need, that you have more than you need, so if you have more and the have comes from the problem, then that's the excess. If you determine that the amount that's given to you in the problem is less than you calculated, than less than you need, then that is your limiting. Method A is best when you need to find a limiting reagent only because that means you would only need to do 1 equation. You don't have to do 2, and you can find your limiting reactant from there. You can use method A to find the theoretical yield as well. Once you find what your limiting is, your limiting reactant is, you use your limiting reactant to find your theoretical yield. All right, method B, you determine the product for each reactant, and the smallest amount of food is the one you use for limiting reactant and is your theoretical yield. So whatever the smallest value is, that tells you what your limiting reactant is. That reactant that gave it to you, that's your limiting. And that smallest value of product or food is your theoretical yield. This is best when you, so method B is best when you need to find the theoretical yield because you already have the answer once you do it. So if you need to find the limiting reactant and theoretical yield or theoretical yield only, use method B as what I suggest, but both methods work fine. Important things to know for both methods, this happens all the time. The problem tells you how much you have. So it's not the number you calculate. It's not in the balance equation. The problem tells you how much you have. You have to think of the problem as your kitchen. What you calculate is how much you need. So remember, you're always calculating how much you need or how much you can produce if you're using method B. But the problem tells you how much you have, how much you need to produce is what you calculate. All right, if there's some additional videos that are linked here, so in case you want some additional help, this is just mole to mole like you saw in the example. In a moment, we're going to take a brief look at more complicated stoichiometry problems. But if you want more help on mole to mole, watch these 2 videos. All right, so now let's look at an example where we are not dealing with mole to mole. In this case, we're asked how many grams of NH3 can you make from 4.0 grams of N2 and 2.0 grams of H2. All right, so since we're asked for the amount of product and we're given 2 values for our reactant, 2 different amounts for our reactants, this is a theoretical yield problem. We don't know which one of these is our limiting, so we would have to figure that out. And we could use method A or method B to get our limiting and then subsequently our theoretical yield. But the only difference between this problem and the previous problems is our values are given to us in grams. We're asked to find our answer in grams, and we're given the reagents in grams. So for this problem, this is where the mole map is super helpful. You're doing the same thing that you did before, but you would use the mole map to help you go from grams to moles, and then from moles to grams. So what do I mean by that? In a problem like this, the way we'd map it out is, let's say we were trying to do method B, and we were trying to figure out how much product we could make from the 4 grams of N2 and the 2 grams of H2. So I would start with, let's say, 4 grams of N2. I would then convert that to moles of N2. I would use my mole ratios in the balanced chemical equation to get the moles of NH3, which is my product. And then from there, I would get the mass of NH3. So again, I'm using method B, trying to figure out how much product I could make from the from each reactant. And I would go from 4 grams of N2 to moles of N2, use the mole ratio to get to moles of NH3, and then mass of NH3. I'll do the same process again for H2. So I start again with the 2 grams of H2, convert that to my moles of H2, then convert that to moles of my product NH3, and then convert that to my mass of NH3. And once I have the 2 masses of NH3, one from that I got from the N2 or the nitrogen, and then one that I got from the H2 or the hydrogen, I would then compare those 2 masses, and the one that's the smallest would be my theoretical yield. So using this mole map is, again, super helpful, and hopefully you had a good enough practice on it so you feel confident using it. All right, here's some more additional videos in case you need help on these sort of like gram to gram limiting reactant and theoretical yield problems. There are 2 more videos linked. You should watch those and do the problems along with, since I didn't show you how to do the work for that here. Anyway, I hope you found this video helpful. Have a quality day.